Hello everybody, welcome to the master class of programming. The programs we will discuss here are: number 1, summation of n natural number, odd and even numbers; number 2, reversing a number, test whether it is palindrome and Armstrong number; number 3, finding out prime numbers, highest common factor and lowest common multiples. Here are some of our previous videos where it was shown to you the approach of how to build up the logic of a program from the scratch. In this master class video in session 1, I will discuss about 3 programs. Number 1, finding the sum of n number of natural numbers. Number 2, finding the sum of all even numbers within n number of natural numbers. Number 3, finding the sum of all odd numbers within n number of natural numbers. The methodology of my discussion is: number 1, concept of logic development by case study table. Number 2, flowchart diagram which helps source code design. Number 3, source code using BlueJ, which is Java development platform. Now suppose we have to make a program in Java on summation of n number of natural numbers, then also summation of even and odd numbers. Here I will not focus on the program syntax of Java. Rather than, I will explain you step by step how to find out the algorithm of the program. For logical development of the program, we should consider the number of natural numbers is small. Here let's consider n equal to 4. Now, as shown here in a tabular format, we shall put the value of input and output values in the table. First row is for the values of input variable I, whose value here is from 1, 2, 3, 4, as we have considered here n equals 4. Second row for the values of output variable s, which in this case is if I equal to 1, then s equal to 1; if I equal to 2, then s equal to 1 plus 2 equal to 3; if I equal to 3, then s equal to 1 plus 2 equal plus 3 equal to 6, like that. If I equal to 4, then s equal to 10. So these values of s will be put in the row of s for the respective values of I. Once we can see this table of input and output value, we have to find a relationship between input and output. Also, we have to find the terminating condition of the program, means how long the program will be continued. Here it is pretty much clear. Now that values of I will be incremented either during exit in while or do loop, or during entry in for loop. This loop is also called an iteration. Therefore, I equal I plus 1 in every iteration. Now the question is how long it will be repeating will be mentioned I and the condition row. Here it is I will be up to 4. So I less than equal to 4 for this example, and in general it will be I less than equal to n, where n is the number of natural numbers. Here value of I and s is initialized in the first column, which is called the declaration of variable. Here I and s will be int type, which means that in the memory when the program will run, it will allocate the memory which is assigned for integer type variable. So this declaration is very much essential. This is like a container where different values of I and s can be stored temporarily in RAM or system memory when the program will be executed. We find that value of s in each column is obtained by the values of I added with value s of previous column. Value of previous column of s is the running sum for the values of all previous columns of I. If I equal to 3, then s is the running sum of all values of I less than 3, which is 1 and 2. Now if this s is added with the present column value of I, then sum from 1 to 3 is obtained. So the statement will be s equals to s plus I. This statement within a loop whose terminating condition will be I less than or equal to 4 for this example, and I less than equal to n for the program. Once we get the initialization condition for action and loop, we may draw the flowchart diagram. Here it is shown. I think it is now self-explanatory. Please check the condition I less than equal done if true loop will continue. Within the loop s equals to s plus I equals to I plus 1. When this condition will be false, the program will print the sum, and it will stop working. Here it is the source code. You may also download it from GitHub link shared in the description. For summation of even numbers, as shown in the source code, the natural numbers have to be checked. If it is divisible by 2, then they are to be considered for sum. For summation of odd numbers, as shown in the source code, the natural numbers have to be checked. If it is not divisible by 2, then they are to be considered for sum. In this master class video in session 2, I will discuss about 3 programs. Number 1, reversing a number. Number 2, check whether a number is palindrome. Number 3, check whether a number is Armstrong number. The methodology of my discussion is case study table, flowchart diagram, source code using BlueJ. Now for reversing a number. For logical development of the program, we should consider a number. Let's consider it 321. Here we have to separate all the digits of the number, which are 3, 2 and 1. Then reverse number can be formed by 1 multiplied by 100 plus 2 multiplied by 10 plus 3. Now as shown here in a tabular format, first row is for the values of input variable I. Second row for the values variable R, which is used for storing remainder values. Third row for the variable rev, which is used for storing the reverse variable, which is the output variable. Initial values of R and rev are 0. If I is divided by 10, then the remainder is 1. So are equal to mod of I and 10. So we can get the last digit of 321. In the next loop, I will be the integer part of I divided by 10 as in table. It is in the next column, which is 32. So I equal to I divided by 10. Now in the next row, the value of rev will the value of previous column of rev multiplied by 10 plus value of present column of I as shown in the table equal to 12. So in 321, last 2 number of digits are reversed. Now how long loop will continue? The condition is, when I equals 0, then the loop will not be continued. So the condition is, I greater than 0, and print of rev will give the output of reverse number. For generalized scenario, the input number I with any number of digits. Condition for loop I greater than 0 in the statement. Within the loop R equal to mod of I and 10, rev equal to rev multiplied by 10 plus R equal to I divided by 10. Now we can make the flowchart diagram of the same. If in the decision box I greater than 0 is true, then statement part will be in the loop. If that is false, it will not enter the loop and print the reverse number, and it ends. Here it is the source code. You may also download it from GitHub link shared in the description. A number is palindrome if it is same after reversing, like 121, 232 in the source code of reversing. Following changes are required. We have to store the input number in a variable. Say it is num. Now num has to be compared with rev. If same, then it is palindrome. A number is Armstrong number if it is same with the sum of cube of its digits, like 153 equals 1 cube plus 5 cube plus 3 cube. For getting the digits of the number, we have to do same operation as we have done in reversing a number. Here remainder R has to be cubed and sum has to be compared with the num. If same, then it is an Armstrong number. In this master class video in final session, I will discuss about 3 programs. Number 1, finding prime numbers within n number of natural numbers. Number 2, 2. Find highest common factor or HCF of two numbers. Number 3. Find lowest common multiples or LCM of two numbers. The methodology of my discussion is case study table, flowchart diagram, source code using blue J. In this video, we will see how to find out the prime numbers within n number of natural numbers. We know that the number except 1, which is divisible by itself, but not by others, is a prime number. Let's consider n equal to 5. Now here in a tabular format, we will show the logic building part of the program. First row is for the values of input variable I, which is number of natural numbers. Here it is 2, 3, 4, 5. Second row for the values variable j, which is used to check whether the number is divisible by itself and by the numbers less than it and greater than 1. For example, the value of j for I equals 4 will be 4, 3, 2. So value of j for each column is the value starting from the value of I of that column to value of the column of I equals 2. So here we find conditions I less than equal to 5. Here which can be generalized as I equals n, where n is the number of natural numbers. Then j equal to I to j equal to 2. In each loop of j, value of j will be decremented j equal to j minus 1, and in the outer loop of I, the value of I will be incremented I equal to I plus 1. In the third row, we will see the count variable will store the number of occasions where natural number is divisible by itself and other numbers greater than 1. So count equal to count plus 1 when mod of I to j equal to 0. That means no remainder when I is divided by j. Here count equal to 1 will be for the numbers which is divisible by itself, not by others. So in the columns where count equals 1 are the prime numbers. Here within 2 to 5, as shown in the table, 2, 3 and 5 are the prime numbers. Now in the flowchart diagram, if I less than equal to n, which is outer loop, start the value of j equal to I. If j greater than equal to, the j loop will continue within that loop. If mod function on I and j equal 0, count equal count plus 1. If count equal 1, then prime number equal to I. If j less than 2, the j loop will end and next I value will be checked for prime numbers. Here it is the source code. You may also download it from GitHub link shared in the description. Now we will find highest common factor of two numbers. Highest common factor is the highest number by which both the numbers are divisible. Now as shown here in a tabular format, we will show the logic building exercise of finding highest common factor of 12 and 8. Here first row, take value of n1 as 8. In the second row, take the value of n2 as 12. In the third row, I will be used to check whether both this number are divisible. Greatest number among those divisible number is highest common factor. If n1 less than n2, then value of I will be from 2 to n1 and vice versa. If we use I less than equal to n1 and I less than equal to n2, then maximum value of I will n1 or n2, whichever is smaller. As we have seen in the prime number case table study, divisibility will be checked in the same manner here as it is seen in the table. Only for I equal to 2 and I equal to 4, both the numbers 12 and 8 are divisible by I. In these cases, HCF equals I as value of I is increasing with I equal to I plus 1. Last updated HCF is the value of HCF. Please have a look at the flowchart where I equal to 2, then value of I is checked less than equal to n1 and n2 / if mod of n1 and I and mod of n2 and I is 0, then HCF equals I and print HCF. Lowest common multiple or LCM is product of two numbers divided by HCF. To find out lowest common multiples of two numbers in the program of highest common factor, we have to add LCM equals N1 multiplied by N2 divided by HCF. Thank you, all viewers, for watching this session. After watching, if you like the video, then please like it. For watching more videos on programming on different language, web development, cybersecurity and artificial intelligence, please subscribe my channel Info and visit infolinksys.net.